So in this video, I'm going to go over adding and subtracting radicals. So let's start off with the do now. It says explain why the radicand in a cube root function can be negative. So remember, the radicand is the number that's inside. So let's say -8 was in here. So this can be negative because -8 is -2 times -2 times -2. These numbers are the same, each being negative. And when you multiply a negative times a negative, you get a positive, and then when you multiply it by the remaining negative, it becomes a negative. So explain why you can have the radicand, which is the inside of the radical, be inside of a cube root function. It's because 3 negatives still make a negative. Okay. So we're going to go over adding and subtracting radicals. The first thing is easy peasy, adding and subtracting like radicals. Basically, you check that the radicals are the same, and then you add the coefficients. So you check for same radical, and then you add or subtract the coefficients. So this is 5 radical 3, and this is 2 square root of 3. So these are the same type of radical, same inside of the radicand. So all I have to do is 5 minus 2, which is 3 rad 3. Okay, this guy here, same deal. There's a 6 and a 6, so I'm going to add my coefficients, so 4 square root of 6. Now with unlike, oh, and there's a little note here. It says we cannot add cube roots and square roots, so they need to be the same type of radical, same index. This is an index of 3, this is an index of 2. And you also cannot add square roots or any radical with the inside being different. They need to be simplified. So the first thing you want to do to add or subtract unlike radicals is simplify them. Simplify the radicals, and then add / subtract the coefficients. Okay, so for example, with letter A here, you cannot add square root of 12 and square root of 75. So you're going to go to your calculator and you're going to look for the perfect square inside of 12. And that'll be 4 and 3. This will give me 2 square root of 3. Now, this is kind of a dead giveaway here. When one of them simplifies to a square root, usually the other one can divide by that same radicand. So if you do 75 divided by 3, you get 25, which is great because 25 is a perfect square. It becomes 5. And now you can do 2 plus 5, which gets you 7 square root of 3. Same thing here. I always look at the smallest radical. I usually take care of that first because it's easiest to see if I need to break it up. The factors of 6 are 6 and 1, 2 and 3. Neither of those numbers pairs have a perfect square in it, so this is completely simplified, which means that most likely these guys can break up into 6 and a perfect square. So in this one, yes, we know 4 times 6 is 24, where 4 is a perfect square. So you get 2 square root of 6 with that. And then let's divide 96 by 6. If you do 96 divided by 6, you end up getting 16. And the 16 reduces to a 4. This 3 will just come outside, and you do 3 times 4 is 12, square root of 6, minus 4 square root of 6, plus 2 square root of 6. And then just add and subtract like radicals. So 12 minus 4 plus 2, that ends up getting you 10 square root of 6. Okay, moving right along. Same deal here. Look at the smallest one. Now again, I would say pause the video right now and see if you can do this one on your own. I'm going to look here, square root of 3 is the smallest one. So I'm going to keep that. Then most likely these will divide by 3. And this one does 9 and 3, which is great because this is 3 square root of 3. Don't forget about that 4 that's on the outside. So I get 12 square root of 3, and I'm going to drop down my 5 square root of 3. Divide this by 3. 48 divided by 3 is 16. So I end up getting 8 times 4 square root of 3, because the square root of 16 is 4, minus 4 times 3 is 32, square root of 3. Then you add your coefficients. So if you combine these, 12 plus 5 minus 32, you get a negative 15 square root of 3. Again, I would always say pause the video, see if you can do it. What I'm going to do is I'm going to always look for the lowest number. So I'm going to look at 20. I'll break that up first. So 4 and 5, I'm picking 4 and 5 because 4 is a perfect square. So I get 3 times 2 square root of 5, which ends up with 6 square root of 5. That means most likely there's a 5 inside of here, and there is 9 and 5. So that'll come out as 3 square root of 5, and I'm not going to forget about the 2. So 2 times 3. This will give me 6 square root of 5, and I'm going to bring that down. And then I'll divide this by 5. 25. 125 divided by 5 is 25. 5 square root of 5, because the square root of 25 is 5. This will drop down. 2/5 times that. This will cancel, so I'll just get 2 square root of 5. If I add these guys together, well, these cancel out because they're opposite, so the answer is just 2 square root of 5. Okay. Moving right along, now we got letters. So, like I said, I usually just simplify the smallest radical first, and then I try to make the other ones match. So, 18, I'm going to break this up into 9 and 2, and x squared can just come out as x, because that's a perfect square. Then I'll get 3 square root of 2x times the 3 that's already out there. So let's just simplify this. 3 times 3 is 9. That x that's out is going to be pulled to the front. So this means that most likely the other two radicals will have x and a radical 2. So I'm going to divide this by 2, and that gets me 16. The square root of x squared is x. So I'm going to simplify the square root of 16 to 4. The x will pull out because it's outside of the radical, so it'll get pulled to the front. I'll break this up. So again, 2 square root of x squared is x. 72 divided by 2 gets you 36. And remember, the goal is when you factor these numbers, you're looking for the number that's a perfect square. Like you're looking to factor 72 where one of those numbers is a perfect square. That's the true goal there. So you get 6 radical 2x. I'm going to pull out, well, first off, let's bring down this half. 1/2 times 6 is 3, and then this x is outside, so it'll go to the front. Now I'm going to combine these 3 things. They all have x's, they all have radical 2's, which means they are like terms, so we can combine them together. So when you combine these, you end up getting 8x, because 3 plus 9 is 12, and 12 minus 4 is 8x square root 2. Okay. So my suggestion would be to pause the video, attempt this problem on your own, then press play and see if you get it right. Okay, so I'm going to break up the smallest radical, which would be this guy right here. That breaks up into 9 and 7. And p squared is just p. So square root of 9 is 3, and the p will pull to the front because it's outside. So most likely 7 will be in the other the radicals. So let's see, 112 divided by 7, that is 16. And the square root of p squared is p. Bring down the 3. So then 3 times, well, square root of 16 is 4. That p will be pulled to the front, square root of 7. So look at me, 3 times 4 is 12, p square root of 7, and I'll bring down this. Okay, dividing this by 7, I get 4 and 7, and square root of p squared is p. Bring down the 2. Okay, so 2 times square root of 4 is 2. The p will come to the front. Square root of 2 times 2 is 4. P rad 7. Adding these guys together, you'll end up getting negative 5p rad 7. Okay. So just keep on going with this. We're going to look at the smallest one and try to simplify that first. 75 breaks up in 25 and 3. So this will become 5 rad 3 times 3/5. The square root of a to the 4th is a squared, and the square root of b to the 6th is b to the 3rd, because remember, power over root. So 4 divided by 2, 6 divided by 2. And then c cannot divide, so we're just going to keep him inside of the square root. Then I'm going to simplify. This 3/5 times 5, the 5's will cancel. I'll end up getting 3, the a squared and the b cubed will pull to the front because they are outside the square root. And then 3 and c will go into the house because they're not perfect. Okay, so the goal really would be to get 3c on the inside of the right side radical. So I'm going to bring down my 1/2, and I'm going to think, well, 3 was inside the other one, so let's see if I can divide 192 by 3. And if I do that, I end up getting 64, which is a great sign, because we all know that 64, the square root of that is 8. A to the 4th will break up into a squared, b to the 6th is b to the 3rd, and then rad c cannot break down anymore because there is a power of 1, and 1 does not divide by 2. 1/2 of 8 is 4. A squared and b to the 3rd will pull to the front, and then square root of 3c. And then you're going to just combine like terms, because now if you notice, this has an a squared and a b cubed and a rad 3c. This has an a squared, a b cubed, and a rad 3c. So these are like terms, so all I have to do is subtract 3 minus 4, and you end up getting -1. But you don't have to show that. I'll just do negative b to the 3rd, rad 3c. Okay. The sum of these two is, okay, so you're going to add these guys together. Alrighty, so this breaks up into 9 and 3. And remember, c cubed has to break up into c squared and c, because you cannot take the square root of c cubed, but you can break it up further. This will become 3 rad 3 square root of c squared is c, and then 3c rad 3c is the way you want to write that, because anything outside of the square root comes to the front, anything inside tails to the end. You're going to do the same thing here. This breaks up into the square root of 4, square root of 3, and then c cubed gets you c squared and c. Square root of 4 is 2, rad 3, square root of c squared is c, and then rad c. And then we end up getting plus 2c rad 3c. And then these guys combine to 5, and that is a choice, 5c rad 3c. All right, so we're going to simplify this bad boy right here. It's pretty much a monster. There's so many things going on here. Okay, so take one thing at a time. Don't try to overwhelm yourself. First off, you want to notice that this is a cube root. So we're looking for perfect cubes. So when I look at 54 and I go to y equals and I divide it by x, like if you do 54 divided by x in the y equals area, you can look at your table and look for the factors. If you also put x cubed into y, the other y equals, so if you had y1 as this and y2 as this, you'd be able to see all the factors of 54 and then all the perfect cubes. So 54 breaks up into 27, I believe, and 2. Good. And let's just clean this up. 3x, this will become cube root of 27 is 3, and then the cube root of 2. So that's taken care of right now. This will be 9x cube root of 2. So right now, at least we've taken care of the numbers. So now you got to think, well, can 5 divide by 3 and can 8 divide by 3? Neither of them do, but we know that we can break up x to the 5th into x to the 3rd and x squared, cube root. The reason why I'm doing this is because the highest number below 5 that's divisible by 3 is x cubed. So then this will cancel out to just be x and then the cube root of x squared. So now that's simplified now. So I get x cube root of x squared. Okay, breaking this up, y to the 8th. So I want to think of the highest number below 8 that's divisible by 3, and that would be 6. Y to the 6th, the cube root of that, and the cube root of y squared. Y to the 6th will become y squared because 6 divided by 3 is 2, and then this would just stay. And then unfortunately, the cube root of z doesn't come out. All right, so now let's clean this up. 9 is the only number, but we do see x and x. That gets you x squared. Y squared comes to the front, and now anyone else left inside of the radical gets left in there. So x squared, y squared, and z. Basically, that's what's going to be on the right side now. Okay? And also, we don't want to forget about the 2. Almost forgot about it. All right, cool. So that was a lot of work right there, and we're going to do it all over again over here for the right one. And then you're going to be able to combine. And, you know, the goal here is that these guys are the same and these guys are the same. So if you want to know a little trick, as long as you did this side and this side right, all you really have to do is simplify the number 128, and then figure out, you know, just subtracting the 2 numbers, and you'll get your answer. But since we're doing this all out, we're going to do this right. So I'm going to break up 128. Now, remember in the other one we have a 2 inside the radical. So if we divide this by 2, we actually get a perfect cube out of it. It's 64 comes out of that. So I'm going to have 6 times 4 cube root of 2. This gets me 24 cube root of 2. Okay, so there you go. You're now done with the numbers. So I'm going to do that, and then I'll do cube root of 2 over here, and I'll just extend this out because we know that's going to be more here. Z is not going to come out of there, so we can just leave that inside the house. And then the 8 and the y are going to break up the same way because they're the x and the y because they're both power of 8. So same thought process as the other side. What's the highest power below 8 that divides by 3? And it would be 6, and you would take the cube root. So 6 divided by 3 is 2, so that would get me x squared, and then the other x squared would stay inside the house, and then I would do the same thing with the y. It would become the cube root of y to the 6th and y squared, because that adds to 8, and then 6 divided by 3 is 2, and that'll come out, and then y squared will stay in there. And now if you notice, these guys are all the same. This is the same as this. So now all I have to do is do 9 minus 24, and 9 minus 24 is negative 15. Very doable. I really suggest if you got stuck there that you just rewind and look at what I just did, but you can definitely handle this on your own. And then I believe there is one more question. It says the sides of the triangle are these, and the perimeter is what? So you're just going to remember that perimeter is when you add up all the sides. Okay, so first off, we should all know that 27 is a perfect cube. It's 3. And then we can go forward with this. So I'm going to think, what's the perfect cube inside of 24? Well, we know 8 is a perfect cube, and 8 times 3 is 24. And you get 3 times the cube root of 8 is 2, cube root of 3, plus 3. This will get me 6 cube root of 3, plus 3. Now, if that's a cube root of 3, this might over here have 3 inside of it, and it does. If you divide this by 3, you end up getting 27, which is a perfect cube. And you'll have 2 times 3 cube root of 3. That's 6 cube root of 3. And 6 plus 6 is 12, and there's a plus 3 just chilling there, so you just add it on. And that's how you add and subtract radicals. So just make sure that the radicals are the same, and you add and subtract the coefficients. Look over this guy up here again, letter I. That's the level you're going to be at, really. That's Algebra 2 level. So hopefully I explained it well enough, and if not, just come to extra help. And I'll see you guys soon.